FATEC Motion Module 11, ECam. This chapter focuses on the sync table in the motion control project. Introduces extensions of the Step 3 in the process of writing a motion control project. This chapter introduces the electronic cam in synchronization mode. Cam table, cam profile, contact output. Cam setting table is located under the Motion Sync Control next to Motion Flow. Here is the interface of the cam setting window. There is a preview chart and an info table that shows the detailed information of the current cam. Users can insert or delete cam points and select from over 21 kinds of cam profiles. This table shows the common cam profile in synchronization control. The calculation method of velocity and acceleration in cubic curve and quintic curve. The units of phase and displacement are %. For example, the velocity of the first part is 50/25. The velocity of the last part is 100/25. This page shows the parameters about cam in synchronization mode. When the cam input phase is within the enable range of the contact output, the output bit of the special register of the slave axis will be set to 1. Next, demonstrate how to use the cam function in Motion Sync Control. Find cam settings. Right-click to add cam 1. Click to open tab. Insert a new data point. The offset of the first row is set to 100%. Select the profile of the cam and select cycloid. The cam setting is complete. Next, apply cam 1 to axis 2. In the synchronization table of axis 2, find the cam settings at the bottom. Set the cam number to 1. The cam stroke is set to 100 mm. Next, go to the basic settings and change the input unit to millimeters. 2 decimal places. The input period is set to 100 mm. Variable gears are 1:1. Back to the PLC program. Connect the M100 to the relay of the synchronous mode on the axis 1. Press V to draw a vertical connecting line. Download and run the PLC. Run M0 to initialize motion control. Run the M100 command to enable the synchronization function. Turn the handwheel for a quarter turn. Axis 1 moves 50 mm forward. Cam to 50% position. Axis 2 moves 100 mm forward. Then turn the handwheel a quarter of a turn. Axis 1 moves 50 mm forward. Cam to 100% position. Axis 2 moves 100 mm backward. Complete a cam cycle. Demonstration complete. Synchronization table. Input phase default value. In the synchronization control flow, the phase of each part is independent. That's why there are initial value settings for each part. For example, the cam input phase default value only affects the initial value of the cam input phase. The parameter of axis base coordinate is used for finding an unknown cam input phase. For example, When the axis base coordinate is set to 40%, the algorithm will use the first solution value as the default initial value. Next, demonstrate the CAM default phase. Open the Axis 2 synchronization parameters table. Set the initial phase of the CAM input to 50 mm. Download and run the PLC. Enable M0 to initialize motion control. Run the M100 command to enable the synchronization function. Turn the handwheel for a quarter turn. The CAM advances from 50% to 100% position. Axis 2 moves 100 mm backward. Demonstration complete. The clutch can control when the input pulses can go through. Here are the connection modes of the clutch in sync table. There are 3 ways to connect the clutch: direct, slide, and follow. This page shows how the clutch connect in direct mode. This page shows how the clutch connects in slide mode. The slide mode allows the sync velocity to accelerate smoothly. This page shows how the clutch connects in follow mode. The follow mode not only allows the sync velocity to accelerate smoothly, but also catches up the position error during connection. This table lists the relevant parameters for the clutch in the synchronization table. The special relays related to the clutch are listed on this page. Parameter mapping. The table lists the item numbers of the parameters mentioned in this chapter in the mapping table. This page shows how the special relay M10622 works to make the mapping value apply in next period. Set the CAM default input phase back to 0. Next, we will demonstrate how to use the mapping table function in a synchronized controlled state. The numerator of the coordinate conversion is 360 and the denominator is 400. Add a mapping table. Map the variable gear numerator in the Axis 3 synchronization table. The register address is R1000. Map the CAM stroke in the Axis 2 synchronization table. The register address is R1002. Back to the PLC program. Parallel Axis 3 synchronous mode on relay at the network of M100. Set function 198. Download and run the PLC. Enable M0 to initialize motion control. Run the M100 command to enable the synchronization function. Turn the handwheel around. Write the DR1000 to 5. RD1002 writes to 50 mm and inputs to 5000. Execute the mapping table. In the synchronization parameter table, you can see that the values have been written. Turn the hand wheel around. The status is not active. With a special relay, the Axis 3 synchronization parameters update immediately. Axis 3 sync parameter update immediately. Turn the hand wheel around. The Axis 3 mapping parameter takes effect. Turn the hand wheel for a quarter turn. A special relay is used to make the Axis 2 synchronization parameter take effect in the next cam cycle. Turn the hand wheel for a quarter turn. The Axis 2 parameter does not take effect. Turn the hand wheel around. The Axis 2 mapping parameter takes effect in the next cycle. Turn the hand wheel around. The Axis 2 mapping parameter takes effect in the next cycle. Application: Nailing machine. An electronic cam combination was used on the nailing machine. Different kinds of cam curves are used in the project, and the cam number is switched using the mapping function.